Okay, hello. It's World of WoqlCraft. So today, this one is the beginner's edition. So if you just like found out this from Twitter or whatever, that congratulations. Like this is for you. This is because I decided to. I have people asking me questions that they've found that World of WoqlCraft is kind of difficult to follow because they may not have done any WoqL with TerminusDB before. So I think maybe it's good that we do a beginner's edition, that we just start from scratch for people who have not used TerminusDB like at all, to how to get started, and how like just how to just start and do something with it. So so first of all, this is the checklist. So this is actually a tutorial that I gave like a few days ago in another conference. It's the Knowledge Graph conference. So yeah, so this is basically is for somebody who is interested to try to experiment and try to learn how to start using having a copy of TerminusDB in their local machine, and to just build their first knowledge graph on the console. So you don't have to install the Python client, you don't have to install the JavaScript client, you just need to get the Docker image. So I believe that in the future we do have other other distribution that is not using Docker, but but today and like for this tutorial purpose, we would use the Docker container because it's the easiest to have a consistent environment for different people on different OS. But if you really don't like Docker, don't worry. We would have, I think my colleague already did a Windows distribution already, and there are more to come. And yeah, there are plans to release it with without restricting people to use Docker. But it's just for today. It's just like, yeah, for demonstration, we're using the Docker image. And so this is the setup checklist that I gave. Usually when I started the tutorial, I want to check whether people have their the Terminus DB installed correctly. So this is a very simple graph for people to follow. So first of all, I mean, usually in a tutorial, for example, in a conference, that I would send over like how to set up in beforehand. So ask whether people already have it. But sometimes people just decided to join last minute, they won't have it. Don't worry, we gotta do it together actually today to see how it goes. Of course, I'm not like actually installing it because I already have it, but I would just like go through it, like talk through it with you. And so it's gonna be you can come back to this video in the future if you have questions, and you don't understand, then you can do this. And so assuming you don't have Terminus installed yet, and I hope that you have Docker. So I'm not going to cover how to install Docker today, because that would be another tutorial for Docker. And so actually it really also depending on your OS. And I think if you're using Linux, congratulations, it's the easiest. And I'm using Mac, so using Mac, it depends on like which version of Mac you're using as well. If you're using newer version of Mac, the newest OS like Catalina or High Sierra, then you should be fairly easy to install Docker as well. You don't need to have a VM. For Windows, I think Windows 10 also support Docker, so it's easy. But yeah, oh, 10 Pro, sorry. Yeah, 10 Pro is fairly easy as well. But if not, then I think you could work around by having installing a virtual machine on your computer. So that would be that would be again like another tutorial. I won't cover how to install a virtual machine. Um, and also there are other like there are a lot of choices of which virtual machine to use as well. So I won't cover that. There'll be another rabbit hole that I would go down. Um, so also today maybe I can show you a little bit of like we also have Heroku. That's like an option. So Heroku is online can I say cloud? Like I'm a bit messed up with this technology, but like for me, I see it as a hosting service that you can it's also like just like Google Cloud and all this, they have instances that you could launch on demand. So we will have a repo that my colleague writes that you could just launch instance of TerminusDB on the Heroku, so you could use it there, use it on the cloud. Um, yeah, and but I gotta first of all go through using the Docker um, the Docker options that you could run locally on your machine. So the way to go is to go to a GitHub repo. So I have a link over there, and just go to our TerminusDB on GitHub and Terminus-quick start. We just decided to rename all our repos, but the link will still be working, so don't worry. But I think the best way to do, so when you go to GitHub, the best way to do is to give it a star. So if you give us a star, then it's like you can always find it back from your GitHub account. So this is a TerminusDB quick start. So you see that, yeah. So it's fairly easy. You don't need to understand what's going on in this one. So the instruction is, as long as you have Docker, you have Git, and sudo. Usually sudo is included, so you don't have to worry too much. And then you just clone this repo. So on your machine, go to your terminal and just type this in, git clone. So to clone this repo, and then once you cloned it, you need to enter this directory. So a lot of time when I give tutorials, I forget to tell people you have to go into the repo. I just assume people would do it naturally, which is something that I overlook a lot. So once you clone it, it may take a bit. It shouldn't take too long. It's not a big thing. You see that we only got a few files here, and then you enter the repo. So within the repo, there are scripts that would use use your Docker to do that. So by the way, when you install Docker, you should also sign up for a Docker Hub account, I believe. So you could yeah, or maybe you don't have to have Docker Hubs to pull it to use. So yeah, so like what this script does is that it would use your Docker and then pull a copy of the TerminusDB Docker image from the Docker Hub, and it will install it locally on your Docker daemon, and then you could use it locally. So when you enter, when you are already in the directory that you just cloned from this repo, you just need to type /, which is like in this directory, run this script, terminus container, and then run. Just run this script for me, and you will see all these things here that is pulling, is getting the newest TerminusDB image from the internet. Of course, like I assume you have internet connection, otherwise it won't work. So and then usually you're just fine. I assume that you don't have it before, right? So you're fine till here. So at the end, you should see that in your terminal saying that it's running somewhere. So actually, maybe I could demonstrate that with my terminal here. So yeah. So ignore the coding bits on the left hand side. Is overwhelming, I know. But look at my terminal on the right hand side. So so you see that we have a terminal, and I do believe I have mine running, but let me stop that and show you how it looks like. Quick start. So I just run the script as well. So now this time I would do stop. Oh, it's not running. Okay, maybe I'll just try run then. I think it's running, but maybe it's not. Right. Yeah, you see that after you run it, you see this, started, and then you will be given a URL to go. So this is where you can access your Terminus console. So let me put it here in my link. Yeah. Yeah, if it's running properly, then you should be able to see a screen similar to this. So let's go back to the big one, so you will see better. So yeah, after that, you would be able to see this screen here. You won't have the other databases. You should only see one, which is a Terminus master database. So I will explain this in a bit. How about let's move away from a bit, and I will talk a little bit about the Heroku options a bit. I'm not using Heroku today, but I would show you a bit. So it's also in our TerminusDB GitHub. So you see that we have we will restructure this a little bit, clean up a little bit. I know it's a bit confusing for people who want to contribute, but we will tidy this up. So we do have a Heroku one. You see, like even I got a little bit lost sometimes. Where is it? Maybe find it. Heroku. Oop. Oh, it's not here. Oh yeah, I think my colleague moved it to somewhere else. So I do believe it's TerminusDB Lab. Like this. Nope, it's not there. Oh my god, I can't access to it. Right. Yeah. If you are my colleague and if you're watching, please help me out. So maybe I would ask my colleague where is it. Just 1 second. Yeah, I do believe that they may have moved it. Right. Okay, I'll come back to this. Sorry about that. I think yeah, we are in the middle of a cleanup, so so it's yeah, it's a little bit confusing at the moment. Yeah, it's not here for some reason. Uh, yeah, because like 2 days ago it was here. I think they just moved it. Sorry about that. Um, so yeah, so you should be able to see this console when it's running locally. So so after that, I think we could maybe start creating a database. How about that? So let's let's go here, and then we would have some steps to do. So we are creating our first knowledge graph, and yeah, we are already there. We can create a database. So ignore the other things. So we're gonna create a new one. So it's quite straightforward that you can see that you need an ID, a title, and a description. So I would say that the ID is required, but the others is optional. But it's good to have a title because your ID can't have special characters, so and spaces. So you would have a name that is super, computer-like. So you may have something like, you know, my first, you know, DB like that. It's not super explanatory. So it could be like. So this is better. And description could be even longer, right? So the description could be which data you're using, the data source that you get it from, or is it like is these data private or is it open that you can share with people? So um, I would because today actually we're using the bike data that is actually here. So bike share. Yep. So this is the data that I'm using. So actually I will explain this a little bit, but what I gotta do is that I gotta be like making a graph, a journey graph with the bike share data. You can even put the link there, like where the data is hosted and or the data source, maybe it's research from this institution and things like that. So you created it. And you can see that if you successfully created it, you should be prompted to this page that you have a first of all, it's successfully created. So this is the message you want to see, and all the information about your graph. So like I said, you have an ID, like a name and description, but also there's also like some URLs here. Uh, so this is actually a this is where your schema is. So when you so if you go to like more advanced stuff, that you would sometimes you specify which graph this object is in. So a schema is its own graph, and also you got your documents in their own graph. So this is how you can refer back to it. And you can see that we are on our local host, so the URL is this one, and the database name, the ID of the database, and it got its schema, and also it got the documents. So these are your data over here. Um, so and so yeah, this I think this is all you need to know. You don't have to know too much about this one, and until maybe we get to more advanced stuff. So you see that it kind of hints you that you have to create a schema, and you can do it with OWL. I will show you in a bit. And you can also create a schema with queries. So I think today I gotta talk about create a schema with queries. That's I think that's easier for beginners, unless you already have experience with graph, that you're very comfortable with OWL. I have people said that, oh, can I create with OWL, because they have more experience with the graph database, and for them using OWL is easier, more flexible. So you could do that, but yeah, but for most of the time, I think, in my opinion, using the query is better. And um, so far, I think there's no questions. But please, if you have questions, type in the chat. I would love to answer it live if I could. Um, so on the left-hand side, you also see that there is, your name of the database, so you know where you are, and these are the things that is specific to your database. So you can be able to inspect if there's any documents in it. Now there's nothing. And you can also inspect if there's any schemas, and now it's nothing. But you can see that from OWL, you have some default here. So this is what you have when you started just create a database and there's nothing. And yeah, you only have the comments and label for the graph. This is all the thing you have. Um, so this the um, this is the name and your the comments, the description, so the name and the description of your graph. So it's not interesting right now. There's nothing. Yeah, so like it also said that you have to have a schema, so you can't do anything right now until you have a schema. So that's what we gotta do next. So yep, and then create a schema, right? So there's actually a script that is prepared for you to easily get a taste of what it is. I gotta open it and show you. So in this repo, there is actually a create schema script that is available here. So um, I could explain this a little bit, and how about we just copy and put that in the console first. So go back here, go to query. So like I said, you can create a schema with query. So we gotta do that. Click on query. You will see that we have a box here. This is an input box that is like a coding IDE. You have your line numbers. It actually do syntax highlighting. You have two options. So you can go to JSON LD, which is the kind of original format of WoqL. WoqL.js is what you're seeing right now. So the syntax is based on JavaScript. So you'll see later when we load in the data, we can basically use syntax of JavaScript to manipulate the query object itself. So these two are interchangeable. I think in the future we also will add WoqLPy. So right now WoqLPy is available, but it's only with the Python client. But in the future you can also use that in console. That's maybe more convenient for people who are more comfortable with Python. So these two are interchangeable. So actually you can try clicking on the other one. So it will just translate it to JSON LD. So this also you can use as a translation tool if you have an application. Let's say if you build your own application and you don't want to use WoqLPy or WoqLJS, you just want to have a way of communicating with the TerminusDB API, then you could write your query in JSON LD. So but if you don't want to write your query in JSON LD, you could use this translator to help you. And this translator actually is built in with is part of the component in the JavaScript client. So you could actually grab it from there. Because we're open source, you can go to our repo actually. Go to our repo, go to our Terminus client, and found that bit of the code and write your own if you want. Use it in your application. And or if you have things in JavaScript, that's much easier. You can just npm install it. Yeah. So you can see that the JSON LD is quite difficult to write manually, right? So It's quite long, but I know that for people who is very familiar with how the schema and things work, this they could use it naturally if they want to. The way going back, you can see that it's a bit different because the code I pasted here before is more like even a higher level code that a lot of function that actually under the hood we use this add quote under the hood. So when we translate back from JSON LD back to WoqlJS, um, we can't wrap it back up with the higher level methods or functions. Then we just use the add quote to direct translate from the JSON LD. So it's not as neat as this one. Oh, yeah, as this one. You can see this is much shorter. So what this is doing? So I'm gonna explain in a bit. So is it big enough for you to see? And let me see if I can make this slightly bigger. Yeah, but like this size is too big now, so maybe not. Right, maybe like this. So yeah. So okay, you see that everything is wrapped up in Woql. Actually it's the end, but we have a Woql when before that. So what is a Woql when? So Woql when is the query that you use um, to update your graph. So there's actually two things you can do with our query here that in this tab. So you can update the graph, like creating a schema or load in the data. It's some you're updating the graph, right? You're making some permanent changes to it. The other thing you can do is you can have a query. You're getting the information back from the graph because, well, what's the point of loading in the data? Because you're just storing there. You need to get it back at some point. So you can query the data but for those query you see afterwards that we won't use Woql when. Those are just queries. It's like your SQL query, select something, something. It's just that. So this is like an update. It's like if compared to SQL, so that would be um, creating a table with this data and or updating a table with that data, right? So Woql when is doing that, but in a way that is different from SQL, and you can see is I would consider Woql is like a Lego. So yeah, you like that's why we have the world of WoqlCraft. So it's like crafting. You're using this Lego to build your own thing. So I think that's the beauty of it, and it's more flexible than SQL. And of course the database even like different. It's different thing. Yeah, shouldn't comparing, but I think it's more easy for lots of people to understand. So we can see that in this within the n. So Woql n is just that it's like a glue. I think it is a glue to glue different queries together. So I want those to I have multiple queries that I want to execute them together. So I use the Woql n to wrap it up. So you can see that there's an n, and then I put these as the arguments of n. So n take in multiple arguments. So we have three things here. So this is the first one. Sorry about that. It's quite difficult to see, but yeah, you can see at the commas so they're separate different things. So this is the first query, and this is the second one, and this is the third one. So there's like three things here. So these three, you can see that they all have the similar structure. They will start with a doc type. So it's a Woql.doc type. So a doc type is creating a document. So remember we have these document here, right? So we are actually creating a document for this. So you can think of like what I usually do is I think of it as an object in the graph, but we call that document because the term object is sometimes confusing with other things. So document is like an object in the graph. So we create three doc types. So there's like three things in a graph, and for each thing, well, we have a label and a description. So they are actually like your database, right? So they have a label and which is the name. That's like human readable name and a description. So this is fairly similar to when you create a database. So actually, when you create a database, is that from the, remember we have the master graph, right? So it's like in the master graph, we create actually, a database, object, and then with the ID and also with its own label and description. Um, yeah. Sorry. I'm still sneeze a lot. Yeah, even though like the hay fever got a little bit better, I still sneeze a lot. Sorry about that. Um, yeah. So you can see the first thing, very standard. It's like your graph. You have ID, you have a name, you have a description. So the second thing is bicycle, and this time we don't put a description because there's nothing very interesting about the bicycle. I can skip it. I told you it's optional. So even when you create database, if you're just doing some tests, you can skip the description. It's optional. Um, so for the journey, this one is more complicated. So you see that it not just got a label, it also got some properties. So what are these properties? So um, so these properties actually is it could be two things. Like a property could be two things. It could be an object property, which actually is a property of the, let's say in this case, the property of the journey, but is itself is also an object. So you can see that it is a station, which is another object. Remember we have a station that describe this journey. So it's a property of this journey. So this is an object property. Um, but the other case that we could have is to have some basic type to describe the property could be a basic data type. So what is a basic data type is something that is very fundamental. For example, like all the things that you could have in a programming language. Imagine like you can have integers. Of course, if you have a program that is originally designed to do calculations, so you have integers, you have decimal numbers, and you can have strings, because like you can't imagine a program that without string is like a calculator. So usually you have strings in your programming language as well. And daytime is very common, especially in the data world, because a lot of data they would have, you have a timestamp, or there's a lifespan of the data. So the datetime is also one of them. Also, some of them is not shown here, like Boolean, or yeah, there's a few more. For example, like integer and decimal numbers. There are different like kind of integers and decimal numbers. So or some of the things like a range, it's a range of things, so it's more complex than just numbers. So those are the data types. So they could also be a property. So property could either be an object property or a data type property. So so you can think the object property are the custom property. That is an object that is you created it before. So it's like, for example, bicycle and station in this case. So you created it before. So you created it in the graph. So this is your object property. It's an object that you created. For the other things, datetimes, integers, they are the data type. So they are actually default. They are the default fundamental properties that is very useful in a lot of cases. So the journey got quite a lot of properties. It got a start station and end station. So they are the stations. And you have an integer, which is the duration. I think it's in minutes or something like that. You have a date time that is for the time stamp that is start and the end of the journey, and a bicycle. So each bicycle is unique. So there's an identifier with it, and actually you can see that from the data. So let's have a look. Let's look at. Oh, it just downloaded. Oh, there's no way of me showing a CSV here, sorry, because I'm using a Mac and I don't have anything like a spreadsheet. I think I have numbers, but I've never used it, and I have to adjust the window and stuff. So unfortunately, I can't show it here. But you can. This is open. This open source, so you can go to this link and find the data. The link is actually in the slide. So what I gotta do is that I gotta put the link. So you can't see it now here, right? So actually I can cheat it a little bit and pull this down so you can see. Yeah, now you can see the link. Yeah, I am putting it down, so at the top of the streaming you should be able to see it. Yeah, so it's just like terminusdb.com/t/data/bikeshare. Yeah, I should have put it in the slides, but forgot. Yeah. So this is your schema. At this point, we haven't done anything yet because we haven't even like pressed submit. So there's still nothing. Don't go away from this page. Don't click on other things. Otherwise, you have to do it again. Nothing has been done yet. So what we gotta do now is that we gotta press on submit. And you can see that we got this little blue thing here saying query return one result in a very short time. And so why is it run with one result and there's nothing we can see here? But it has done something, obviously. So we got one result back. Is kind of like a ping back from the server that is done. It's good. Everything's good. We don't have errors. So this is what it is. And it's not actually anything related to data. Remember, we are using Wacko when we're updating the graph. We are not having a query and getting the data back. We're just putting something on the graph. In this case, we are putting a schema structure to the schema graph. So we don't even deal with data at this stage. So that's why we have nothing coming back. So, but in the future, when in a bit, when I show you the query, you see that this will show you the query. But that's afterwards. So now we have our schema. So let's inspect to see if we have the schema. So we can click on the schema here now, and we have something. We do have something. We have a remember we have free class, so free things in the the doc type thing here. So we have the name, we have the description. They are the documents. So we create a doc type, right? Remember? So we created they are the documents. They should be, when you put a bicycle there, it should be a document. When I put a journey there, it should be a document. So, and what you can do is that so these are the classes. You can also look at the properties. Remember, we create a lot of property for journey. So let's have a look. Oops. So yeah, these are the properties of journey. So you can see that the domain is journey, which means that these are the property of the journey. Type, you can see that what they are. So you can see there's SCM and XSD. So it kind of, you can see there's two types that I talk about, right? So there's the data type, and this is the object properties. So this is the data type property and the object type property. They have their own name, and they have their own ID. So yeah, so we did what this is what we expected. And OWL got more things now. I won't go deep into it, but you got things in OWL, so congratulations. Because yeah, actually it reflects here. So if we have things here is in OWL, it's just a different way of looking at it. So schema is done. Congratulations, schema is done. In my opinion, schema is the most important part when you started to create a graph, because it defines how your graph is structured. And when you load the data, you just follow this structure to load your data. Okay, so yeah, we have done that. Now we load the data. Yeah. Oh no, actually we can inspect the data first. So like I said, I can't just open like a spreadsheet with this, right? So what? But we can actually inspect that in our console. So forget which one. Okay, this one. Yeah. So this is the repo is what all the script is sitting. So this is actually something that I write for the meetup before. And so yeah, this is actually so yeah, this is the script I prepared for the event for the meetup. But there's also a detailed blog post tutorial that have all these available, so you don't have to get this now. And what I gotta show you is that I gotta show you the blog at the end, so you know where to find the blog, which is basically what I tell you today in a text format. So you could get all this code there. If you forget any steps, you can refer back to that. So don't worry if you don't have the link for this one for now. So yeah, so now we have to inspect the data. So the script is in loaddata.js. So this is a bigger script. So you see, actually, I would break this down into 3 steps. So at the first steps, we have CSV equal to a query, and we have wangles equal to a list of queries. And so input is just combining the CSV and the wangles. And in search is another query, and this one is a Wacko yeah, it's a okay. Yeah, it's a using an insert and something, and then at the end we use Wacko when to update it. So at the end you see here at the end this one. I hope my highlighting is working. Okay, so this is updating the graph. So uh, I gotta show you bit by bit. Let's get this CSV bit first. So I gotta just copy this thing here, right? And okay, go back to the query. So I have a fresh new block that I could use with this. And actually, I don't want this const CSV now because, like I said, in that script that I just showed you, actually we use the syntax of JavaScript to combine the queries together. It's more easy to read and understand, but right now we're just inspecting, so we don't need that. We just call Waco get and have all these Waco s and then remote. So what are they? Um, so get is actually grabbing the data. So it's get from where? From a remote source. So so this is actually, as I told you, is hosted on TerminusDB /t, that's /data, right? So this is a remote host. So it's something host on the internet. So use a remote. So if you have a local file, you could use file. And for the details, again, I will show you the blog post that explain that at the end. But you could totally load a local file. It's just slightly different. You just need to change it into file, and this would work slightly differently. So okay, so get, within get we have all these s. So what are these things? So you can see that we have all these, it looks like some data, right? So these are actually the column names. You will see it in a bit. So this is the column name, and we um, load in the whole column and refer them as something else. So whenever you see a v colon in a parameter then you know that this would be a variable in a query. So you can refer back to this start station later in the query. So you will see this again actually in the data wrangles. And so you just because in when you are building the queries in the future, in what's following, how do you refer to back to that column? And you can't just call the column name. So this is why we have this Waco s. And also because now we are loading this, so where sorry, oh yeah, because again, like, sorry for the new viewers, yeah, my headset turned itself off because there's no sound input. Sorry about that. So yeah, I don't know when I got when I lost you. So yes, so maybe I'll just repeat slightly before. So you see that now we have inspect the data and we have all these columns. So these columns, like as described before, we have integers here, we have an ID for bike, we have all these timestamps for start and the beginning, and yeah. So so yeah, this is what this query is doing. So so it's this actually very neat, but we will have we have a more exciting version coming up when we release Hub that you could do time travel and all these exciting stuff. Um, but right now this is still very cool because, for example, I want to keep this even though it's very long. I want to keep this because when I build my query, I want to keep this as a reference. So what you can do is that you can click on this little thing at the end to add a new box, so you won't mess up the previous one. You can always scroll back up to refer back to what this data is. So I found it useful. Like, this is like a Jupyter notebook because I work in data science before, and in the Jupyter notebook we could we need to inspect the data all the time. That's why we have these like pandas.hat to look at the data. So this is quite useful to open a new one. So especially when you're building the query. So now I'm cheating. I copy the script that I have done before. But if you are, if you hasn't, is building from scratch, then you have to, look at the data, saying like, okay, what this is an integer? Yes, okay, so you can do that. So okay, let's explain this script. So sorry about the scrolling, I'm like messing around. Okay, so this bit I've explained it before. So now this time, instead of print just giving me the result, I want to store this query object in something called CSV. So this is this, and we have the data wangles. Like I said, wangle is a list of queries. So this list of queries, we have actually three things. So we have typecast, IDGen, and concat. So typecast is for example, like the thing that I explained before. So we have some properties that they're data type. So for data type, like any data manipulation, data cleaning, so when you read in a CSV, it's default as a string. So if you do nothing about it, it's just like a string. It's like when you query your make a SQL query, everything in return will be a string. You have to cast them into different things when you want to, let's say, do your machine learning and anything. Um, so here we can actually, the good thing about using TerminusDB is that because we also store the type of this data, so you can just cast it and it's already like there as an integer. You can cast it, cast the duration. So remember, duration is something that we input here. So we can refer back to this column duration because like now we have the v, which is the variable, and we can call it back here, right? So this is matching the duration, and it is an integer. So please cast it as an integer. So, and the last thing is like, because we need to store this new thing. So actually now we have two duration variable. One is the original one, which is a string, and the new one is called duration cast. So when we input the data into our data graph, then we actually need to use duration cast instead, because remember when we build our schema, it should be a type of integer. So if we put in the duration, which is a string, then an error will occur. You get a violation. Which I'm really scared of the violation error thing. Yeah, so don't make a mistake. Um, so yeah, like same thing for the bike label. The bike label is here. Actually, it's the bike. So it's this one, right? So this one is um, so it's a string. So it's fine. We just need to make sure. Actually, I think the default is string, but to be like correct, yeah, cast it as a string, as a bike label. And the time is the daytime. Oh, I know why we have to do that. Sorry, because remember we saw one without the W, right? So it's a bit ambiguous, so it's better to cast it as a string. Yeah, it's better to tell, to be exact. So yeah, it's a good practice because you may have some unclean data that give you a problem. Um, and again for time, same, so we save it as a different name. And so okay, so these are the data type object. So IDGen is useful for all your documents and your object property. Because remember, when we have a table, a CSV table, we are now calling them by their column. But when we put it in a graph, it's not a tabular format, right? So everything is an object and they relate to each other by its own way. So that's why for each cell in a table, it needs to become its own object. So this is what it's doing. It's generating an ID for each cell, rather than now we just generically call them by their own, by their column name. So this is what we're doing. So first thing, we want a prefix. So uh, usually it's just like what this column is, because all these objects in this column, they're all journeys, or they're all stations, or they're all bikes. So they're same type of things. It's good to add the prefix there. Otherwise, just be a bunch of random numbers that you have no clue what they are. It's super difficult to code as well. So put in the prefix that describe what it is. And okay, the second thing is a bit tricky for journey. I think I'll use station as an example because it's simpler. So a station is a station, where the prefix is a station, so we know it's a station. So when we generate the ID, so what is used to determine this object is unique. So for station, it's very straightforward because we have this start ID. It shouldn't be start ID. I don't know why. Oh yeah, maybe. Oh sorry, the naming is a bit confusing. Sorry. So let's look at start ID is the start station number. Yeah. So like we want to use the start station number to identify this this station object. So you can see that actually station got a little bit of catch as well, because we also have the NID, and you can see that we also give a prefix of station for the NID. So okay, question: what if let's say I have a station, let's call that let's call it bank, bank station, outside of bank, is a the station in London that it has a the ID is bank 123. Let's say it's just next to the tube station, bank 123. So bank 123 is so somebody grab a bike there, so it's the start of the journey, so it's a start ID of some of one journey. But bank 123 could also be an end ID of a journey, because somebody may end the trip there, they just park their bike there and leave. So um so that's why it's very good to have these two, because um, if we use the start ID and end ID, if the data is clean, then they should be the same ID here, right? So let's look back at the data. So you see that all these ID actually related to the exact same station. So this one, this number 31615, could also be appearing in NID. And because we're using this as an identifier, that's the station that we created here. Actually, they will be the same station. So we can identify the same station no matter whether they are at a start station or an end station. So this is good. So for journey, it's a little bit complex because, sorry, I skipped this bit. So the third argument, so we have first argument, the prefix, the second argument, and the last argument would be where you store them. So we just store them, as another variable. So the journey is a little bit complex because we don't have a column called journey ID, right? So how we're going to generate a journey is that we use three things to identify a journey. We use a start ID, a start time, and a bike. So what does that mean? So if you are hiring the same bike from the same place at the same time, it should be considered as one journey, because you can't have two person making two journeys hiring the same bike from the same place and at the same time, right? It would be a paradox. It would like break the law of the universe. So it's impossible. So that's why using this three we can identify a journey. So again, save it in another variable that we use in the following. Okay, concard. So concard is like your formatter string. If you have some programming experience, JavaScript and Python also have this. It's a formatter string that you have a string, and then inside you can put variables in it. So it got replaced by the variable when you run it programmatically. So you can see that we have the v. Remember, the v is the variable, right? So we have start ID, and there's NID, so it's like from where to where, and the time, at which time. So we concatenate it together to make it like journey label that we're gonna use when we insert the data. The same with so this is more like a human readable description, right? So it's like bike, 1, 2, 3, 4, I don't know, from, start station could be, a bank 1, 2, 3, like I said, to O Street 2, 3, 4, at a start time, at 2 p.m. Today, not 7th of May, like it's 9. I can't remember today. I'm like working too much. Yeah, so so this is the description that kind of all these variable will be filled in with the variable that you load in and clean. So it will be here. So that's 2-bit. So like I said, these two will be combined with a WoqlN. Remember, WoqlN is a glue, so it will stick two together. So actually, this is not just sticking two together; it's sticking CSV and many wangles. So it's a list of wangles, right? So you dot dot dot. If you don't know JavaScript, it's like unpacking. So it's like, okay, taking everything in this list and remove the wrapper. So it's not a list now. It's just many things. And you use a and to join CSV and many things in the wangles together. So this is what it's doing. So it become one WoqL query object instead of CSV and many things, or a list of things. Okay, so now we have the inputs ready. So these data, I loaded in, I have a reference to it, to all these columns, and I do the data wangles. I change the type. I reformatted them a little bit so it's ready. So all these is ready, but hasn't been input to the graph yet. So this is the bit that I say is like you just so the insert is the bit that you just need to follow what your schema is, because you see that it's highly similar to your schema. We have actually 4 things here because the station is applied to the end and the start station, so that's why we have duplicates. But otherwise, it's just the same. We have the bike, it got the ID and the label, so it's just like our schema. So station we have 2, but still, we have the start and end station, and the label is just station. So these inserts are the first thing is so what they are actually the ID of them. So we call them URL during our wangles, I believe. Yeah. So when we wangle them, we just call it URL because we're running out of name. We can't call it ID again. So we just call it URL. So yeah. So these are the IDs that we created from all these inputs above. And what it is a station. Remember it's a station, and so that's how you insert. This is very simple. And label is even simpler. You just put, oh, this is, you just need a string. So this is a string that we created before. Some of them are the concards. Remember the journeys. We have this label is concard, so we create that from the concard. So your journey, but remember journey, we have, not just the label and description. We also have the properties, right? So for the properties, is almost the same as insert. But this is the other way around. This is what it is. So it's start time and the actual thing in here, because this could be this could be a data type, or it could be an ID of an object. So yeah. So this just refer back to what we have in the wangles. So and like I said before, at the end you have these inputs and inserts. You do an update. So you call a Wacko when to put that in there. You have the inputs, and then so basically it's like preparing the data, and then once you have it, and then you would run the insert to update your graph. So now you have the data. So seems a lot of work, but imagine you have to put in all these objects one by one. That's even more complex. That's what I recently do with World of WoqlCraft. We do things programmatically because not every time the things are so clean. So I assure you that's more complex than this. So this is actually fairly easy. You just need to get your head around to use Wacko in a proper way. So okay, let's run it. We haven't done anything yet. We hasn't pressed submit, so let's press it. So yep, you see that we have one result and nothing here showing. Why? Remember when we run the Wacko when before with the schema, we're updating it. So after we update the graph, it won't be any result. It's not like what we've done before, right? So it's just just one thing return saying like everything's fine. That's it. So we won't have anything to shown here. But you can actually click on documents and see we have many things here now. All these is from the CSV, and you can see that we have the bicycle, and then the ID is generated from from that bicycle ID. You can click on it as well to see the what is related. Yeah. So sorry. Let's go back. I accidentally click on the wrong button. Yeah, it's fine. We have already clicked submit, so it's here. Right. So yeah, all these are here. So but by the way, there's like a limit that we're not showing everything. That's why we can actually like search for it if you want. But I think what is better if we make a query to get the data back. So right. So okay, query. We will run the script. I just realized that we have been an hour already. I was like really explaining in detail, so hopefully it's gonna be fine with you to stay and watch. So so we have the query.js in our script here. So again, like I said, this all will be available in a blog post, which I'm gonna show you at the end. So I have this query you can see it's different from what we have done before. So, but we still use the query tab. So everything is done here in query, which is amazing. So put this back here. So from like put what I copy in here. So you see that we don't have a WoqL when anymore. So this is not updating the graph. This is getting the data from the graph. And we have the WoqL.select and some triple op, or what are these? So I'm going to show you without the WoqL select first, just for explanation. So we have a bunch of triples. So triple is that everything in the graph is a triple or quad. Quad just like has the specific, which graph you're referring to. So remember when we do the WoqL when for the schema, that when we come back from the JSON LD, we have a lot of add quads. So what are these? So it just means that, or I have these relations, put that in the schema graph for me, please. So triple is like without the last thing, so it's not. We don't have to say that, oh, it's in the schema graph. So if you want to query something from the schema graph, you would put a quad here instead of triple. Quad means 4 things, right? So so all the relations can be described with 3 things. So that's why we have the triple here. So it's the object, predicate, and subject, and for the 4th thing, so when you use quads, so there's the 4th thing, which is the graph that you want to specify. So if you are doing things, just within your documents graph, that is the default. You don't have to specify that. You don't have to put your graph ID in that. But if you are doing things about your schema, then you have to specify. Oh, actually, I mean the schema. So triples. So let's explain this a little bit. So you see that I want on the journeys, again, variable. So any journey that matches this thing. So actually anything that matches these two, call it journey. So what are these two? So it's like something. So this is a variable, right? So something that is a type of journey. So these things need to be a journey. So give me this thing. So that's the first triple. So the second triple. So the thing that I talked about in the previous triple, and it got a start station of some start station. So give me that start station as well. And so ignore the ops for now. So so for that start station that I mentioned in my previous triple, and it got a label that is a start label. Give me that as well. I want that as well. So similar to the end station, I want end and enable. Please give me that. And the last one is that for the journey that I talked about in my first triple, it got the journey bicycle and give me that bicycle as well. So so basically you're like asking the graph database to like give me this, and anything related to it, give me that as well. So it's like yeah, you're just like grabbing things, from the graph. Like I want this, and then what is related to it, give it to me as well. So let's submit it and see how it looks like. So you see that we got something which is good, and we got this is a table, and it's super similar to what you would do, with a a relational database using SQL. It would be something like this, and but what it is. So remember we asked for the journey, so you have it, and then ask for the start and the end station of journey and its corresponding label. You got that, and you got a bike. So you got all of them. So okay, let me explain the opt. So opt is it means that if unfortunately one of the station is missing a label, so if you run it without the opt, but I do believe that our data is clean enough that this will still be working. Yeah, so this will still be working. But what opt means that if your data is not clean, if somebody is missing a label, somebody forgot to put a label there, so the one that without the opt will give you an error because I can't find it. Sorry, I can't find it. I've just like error, I can't find it. But if you put an opt, you just say that, oh, by the way, if you don't have the label, don't worry about it. Just skip it, and don't give me an error. I don't care. So this is what it is. It means, and so yeah, you can see that it works. And so let's put the select back here. Oh, okay. Let's put the select back here. So what does that mean? So remember this one. We have 1, 2, 3, 1, 2, 3, 4, 5, 6. We have 6 column here. So because we asked for journey, we asked for the start and the start label, and an end label, and bike. So we have 6 things. So select only have 4 things. So start, start label, and an end label. So let's try to run it. And now we only got 4 things. So it's the same as your SQL select, which means that I only care about these 4 variables. So instead of like, oh, give me these 4 columns. So well, it's presented as a column, but it could be a presented other way. I'll show you. But you are just saying that like I only want this. I only care about these 4 variables. Just show me these 4. The journey, I still have to use journey in the query because you remember when I grab things, I need to use journey as a anchor point that like to relate things, right? But at the end, I don't care about journey. I just care about all these things that belongs to the same journey. So yeah, that's why select is useful in this case. So like I said, it doesn't need to be a table. Otherwise, it's just like SQL, where you can use it that way. But that's not the advantage of using a graph database because these are all the relations, right? And we may want to find out that, where a bike go, maybe from station A, somebody hired to go to station B. It could sit and say station B for days or weeks, I don't know. But somebody in some time hired the same bike, go from station B to station C. We want to know that. So how to look at it is to present it as a graph. So see these 3 buttons here. So this one, I don't know whether you can see my cursor, but you see the left one. There's a test tube, and there's the one that is is highlighted right now is the table, and the one on the right of it is the graph. So if we click on the graph, whoa, we see all these things. That is, well, now it's just a dot with a funny icon like a person there, and we have some arrows. So what does that mean? So actually you can, I don't know whether you can see, you can click on it, it get bigger. I don't want to make it bigger. Can you see I think you can't see the mouse on. So, okay, so what happened is that these little dots, they are like different documents in it. So remember we have all these things, right? We have this, the start and the start label and end label. So all these dots are either one of them. So it could be something that is a start station, ID. It could be a start station label. It could be a end station ID. It could be end station label. So it could be either one of them. And all these arrow means that they have a relations. It doesn't need to be any relation. So it could be a bike go from a start to an end, but it could also mean that this station got a label. So let's see, this one could be I have this is a station, so maybe I go to the other station, so this is the end station, but this one is my label. So the relations of these arrows are a bit ambiguous. So this is not a very nice graph. So how are we going to have something that makes sense? So go back to our cheating script, cheating time, and go to the view.js. So this is the view script. So let me copy this, and I'm gonna explain. So okay, first things first, don't put it in here. This is our query. We need them. We still haven't done with it yet. We're still looking at the query that it returned back. We just want a different presentation. So don't touch the query. You need them. So how are we gonna put the view script? So remember our test tube. So press on the test tube. So you see that now we have a new thing that you could, a new box that you could put some code in. But this box seems a little bit different, It's still got the WoqlJS and JSON LD, but it will give me this view equals to view.graph thing. And and it actually, if you look very carefully, you see that there's outside boundary here that actually is bounding these two, right? Remember, if we click on the new query, we got a new box here. So this still belongs to the same box. So this is the same, still in the same query. So this is actually where you put the script that you can control the look of your graph. So if we go paste the script that we just copy, and you see that. So how about we just update it first, and I will explain. So now you can see the look is totally different when you update the view, and we got all these little bike icon, and it's now red. And actually you can't see it right now, but if I put my mouse on it, it will show me the label of that station, so the name of that station. And so now all these purple arrow actually means a journey, means that there's a journey from this station to this station, and it doesn't need to be continuous. Maybe somebody in the future just hire the same bike and continue. Um, so yeah, so let's explain. So first, view equals to view.graph is essential because it just means that I'm now doing the graph view. You can change it to table and it will go back to a table view, but it's not necessary because we are not interested in the table anymore. Um, so we have a note. So so we are just telling that, so remember we have four things, right? So those dots, which are notes, could either be any of the thing in here. It could be start label, and end label. So here I'm just saying that, like, for those dots that represent a label, hide it. I don't want to see those as a dot. I only want to see the station itself as a dot. I don't want to see the label as a dot. The label, I just want it to be a text that show the label. So you will see them back in the picture later. So for the nooks, that is an endpoint. I just want to have a different color. You can actually change it. Let's say I want to change this into green actually. So I can change it into green actually. So if I update it again, so you can now see all these end labels are now green. This is a bit funny because it is like it start and the end at the same time. But look at this one, like um so yeah. But why the arrows are in reverse? That's so strange. Yeah, we may have to change a little bit of this one as well. Because now it's pointing from the end to the start, so it's a bit like counterintuitive. So we have to make some changes to the edge as well. But anyway, um, yeah. So the label of it will become a text, which is the one that I can't show you because of the limitation of the streaming setup. But when you put your mouse on the icon, it will actually show you the label. So we make them bigger. Remember, we used to have a smaller dot. And oh, this Unicode means that you change the from that little person into a bike. So if you want, you can put an emoji there. I think it may look a little bit different from what the emoji you're used to, but you can put, because a emoji is a Unicode, right? So you can put it there. So the charges just mean that how far they are apart. So it gives you a nicer graph if it's not clustered together. Um, Same with collation radius. So it's just another way to separate the nodes so it doesn't cluster. Weight is making the edge more viewable. So now it's still like too light in my liking, but yeah, this is what you do with the arrows. So let me fix that start and the end thing. So why is it pointing from the end to the start? This is funny. So let me change that. Yeah. So now it should work. Let's see. Nope, it's still. Uh, I have to have deeper think of why this is the case. That is so funny. Yeah, that is like from the end to start. Hmm? Yeah, the start is red, so I don't know. I would have a deeper look in it and why the arrows are going crazy. Um, but in general, this is how you change the look of it. And this view script now is only available in JavaScript version. But in the future, we'll try to implement it in Python, and also maybe hopefully you can use it with Jupyter Notebook. I think which is something very handy for data scientists and people do data analysis, and or even you just want to inspect your data. So yeah, I think that's it from this demo. At the end, I promised to show you the blogs that you could find all these tutorial, and it could answer some of your questions. And so the blog is like at our website, terminusdb.com, blog or blogs. I do have it. Yeah, blog, and with an N and slash there. So So you can see all these like news and articles about it, but if you dig deeper, I mean really dig deeper, a lot more, and you see that this one is a tutorial that is like how to load the data in a turtle file. So what I show you today is how to load it in CSV, but why I'm disappearing is funny. Sorry. So yeah, this is how you load in the data not in CSV but in a turtle RDF. So I think there's a lot of interest in this because actually our graph is it works very well with RDF because like a part of the structure and the design is using RDF as well. So the ontology, remember like that I showed that owl thing. So yeah, so actually it could be nice like to load it in the turtle RDF, and this one show you how. Actually, it's fairly simple as well. Um, um, Local file. So this is a question that people ask a lot. That oh, I don't want to like I do I have to host my data on the internet? No, you don't have to. You can just like you know uh, load it locally. So you can go here and see the tutorial here. It goes like in details. On this tutorial will be here. My first TerminusDB graph visualization. So this is the tutorial that I covered today. So this one go also into detail. So you can go to this one to grab all the scripts as well. And so this is our blog. And if after you have read the blog you still have the questions, what you can do is to join a Discord. So you just go there, click on the link, join the Discord, and trust me, like everybody there is amazing, and we just want to to answer your questions and help you there, or give us feedback or share your creations, anything. Just go to Discord and we'll welcome you with an open arm and try to help you. So I think it's a bit long today, and thank you so much for watching. Thank you so much for having interest to learn, Wacko and how to use Terminus DB. And I think it's something that is very useful for a lot of projects. And like I said, it's like a Lego. You can build it with different things. I'm still looking for something to build next week, and I hope there's some inspiration from the Discord group. And I just hope to have more variety of different cases to so people can get inspiration and have fun. Have fun is very important. So yep, I'll see you next week, and if not on Discord earlier. So yeah, thank you so much. Bye bye.